Good morning everyone. Today we will discuss about how to find the lowest common ancestor in a binary tree. Let's take an example of this given binary tree where the root starts from node 9. I need to find the lowest common ancestor for node with value 7 and 2. So my first job will be to do a depth first search to find node 7 and 2. So once I'm able to find them, I need to look for their lowest common ancestor by coming back from all those recursive calls. So for this case, node with value 4 will be my lowest common ancestor for both of this node 7 and 2. Let's take another example. For this case, my lowest common ancestor for node 1 and 3 will be node 1 because node 1 is both the immediate and the lowest common ancestor for this case. Let's try to understand and go through the problem once more. So here again 9 will be my root node and we'll do a depth first search to find nodes 7 and 2. We'll go from node 9 to my left node 4 and again to my left node 7. Hey, I'm able to find my first node. So coming back from my recursive call, it will return this node to my parent node 4. As I got my first node, I will see if I'm able to get another while exploring the right side of the parent node 4. So I will go to node 1 and then 2. I will wait here till the search is ended from the right side of this parent node. If I'm able to find both nodes while sitting at node 4, I can say node 4 is the lowest common ancestor for these nodes, that is 7 and 2. 9 is also the ancestor for these nodes, but it is not the lowest one. Now let's look into its implementation. So here is my definition of binary tree node with the class named tree node. It contains value and the node left and right of type tree node itself with a constructor which helps me to initialize node with its value. This lowest common ancestor function takes root node and two nodes for which I need to find my lowest common ancestor. So the first part is to check if the root is null or not. If it is, it will return null, else it will continue with the execution. If root is equal to p or root is equal to q, p and q are the nodes that I need to look up. So if I'm able to find any one of them, so I just need to return it in the recursive call. And again I will explore the left part of the nodes and the right part of the nodes. So while I'm sitting at any particular node, if I'm able to find both the left node and the right node, I will just return the root. The example which we took earlier, for this case it will be the node with value 4, and the last part will be that if right node is null, so I just need to return the left node, if it is not, the right node. Just remember when I talked about the wait part when I was sitting on node 4. So this code will help me to do that. Thank you for watching it. Please subscribe to watch more and please comment in case of any doubt.